Okay, now there's another style of question. Now in this case we're going to make x a subject. Let's pick one first. Okay, no, this one. Okay, we write over here. Let's do question number 2. Square root x plus 1 equal to 5. Okay, now you can see this square root, but then there's a bracket. What does it mean? It means the square root apply to both x plus 1. If I write as square root x plus 1 equal to 5, it means the square root only apply to, even without the top bar, say no. That means the square root apply to x only, it doesn't apply to 1. Okay, so if I put a bracket, like for example this question, you put a bracket, that means the square root apply to x plus 1. Okay, now, so x plus 1 is a square root 5. Now, I square both sides now. Okay, what is the meaning of square both sides? This half, we square it. Okay, then the 5, I also square it. Okay, now 2 times 1 cancel, so left with 1 over 1. So finally what you get is x plus 1 equal to 5 to the power 2 is 25. So x become 25 minus 1 is equal to 24. Okay, now let's look at number 7. Okay, square root ax plus b, remember the bracket. Okay, now if I lengthen this bar here until exceed b, so in this case you don't need to put a bracket. Why? Because obviously the square root apply from ax plus until b. Okay, now remember this ax plus b is actually equal to half, as I explained in the indices chapter earlier. Now, so what I do is I square both sides, ax plus b, whole thing half, I square it. Whatever I do on the left, I do it on the right. So this side also I square it. So this cancel, so it's 1, 1. So ax plus b to the power of 1. So I just write ax plus b. This side will become c squared. Now I want a as the subject. So first I have to remove the non-x term and move it to the right hand side. Okay. Now after that, I'm going to move the a to become the denominator of the right hand side. Okay. So this become c squared minus b over a. Okay. Now, what about 9? Show you another example. 9. Okay. Is b equal to square root gx minus 1 square. Now, I square both sides. I don't want to repeat the step, but obviously you square this side, this square root disappeared. It becomes gx minus 1. So b squared plus 1 equal to gx. Okay, the g, move it down to the other side and make it become the denominator. That's it. Okay, now let's look at something that's more complicated. Okay, what about this? Okay, what about this? This 17. This is square root ax plus b and square root d. Okay. Now, this square root, this one is equal to square root of this. Okay. Both also square root. So therefore, whatever inside the square root must be the same. Therefore, ax plus b must equal to d. Okay. So ax equal to d minus b. Now, again the same thing. D minus b, I'm going to bring the a to the other side as the denominator. You see? Okay. Now, what about 18? 18, I square both sides. I will end up on the left hand side, x minus d. But this one originally was a square. I square it again. When I want to square this, you end up become a to the power of 4. Okay? Now, therefore, x, I bring this over here, become plus d. Okay? Now, what about this? Where you don't have square root, where you have square. For example, this. What you do is x square, bring it over here, 17 minus 1, which gives you 16. Now, this x square equal to 16. Now, so I want x. So x become square root 16. Remember, if you x square and you want to find x, you have to put the plus minus. So this gives you plus minus 4. Okay? Okay? Like this one, very straightforward. You want x. Then this one, g become square root of g. Okay? Now, you unknown, you square it, you want to find x. So, as I said earlier, you must show plus minus. Okay? That's it for this.